So we're going to create a new XCODE project. You are then going to be prompted to select a project template. Here we're going to select app as our prototype. It was an app for iOS. And then we're going to enter our product name, select our team or organization identifier, and then for interface, be sure to select storyboard and your language as Swift. Next, it's going to prompt me to create a folder to host a local repository in. I'm going to select Create Git Repository on my MacBook to enable this. And now we are all set, and it's going to display to us our very first template. That you're going to be displayed is the general settings. Here you can set the display name, which is what the user will see underneath their app icon on their phone. The deployment target is the lowest iOS version that your app can work for. It defaults to iOS 4.4, which is the newest iOS. But if you want it to run on older versions, you can move it down to, for example, iOS 13. You can set your device orientation, and you can also set what your app icon will be and what the launch screen file would be. Also, here is where you would set your embedded libraries and content. There's a host of other settings, but what is important is that you know where to find it. Beyond the settings screen, you are going to see 3 sections which make up the interface of XCODE. The first section, which you see on the right-hand side, is the project navigator, where you can browse and select all the files that make up the app. When you first begin, there are a few key files. The first is app.delegate.swift source file. It has 2 primary functions. It defines the app delegate class, where the app contents are drawn, and where state transitions are responded to. It is the entry point of your app and has the run root that delivers input events. The next file is a viewcontroller.swift, which provides the code corresponding to our first scene, view controller scene, and the main storyboard. Main storyboard hosts the UI interface for all of the screens. The assets is what holds all of our assets, such as images, colors, etc. And then there's the launch storyboard file, which is where our app is launched. The third panel on the right-hand side also changes depending on what you have selected in the Project Explorer. Its main use comes when using storyboard. I'm going to click on main storyboard in the Project Explorer. The main panel then changes to the graphical interface for view controllers, aka screens, that make up my app. The storyboard is where you can add objects to your app, like buttons, images, or screen sections. Each screen is made up of a view controller and its corresponding Swift code file. As you can see now in the third panel, you can view the properties of the UI view controller. You can change the properties, the sizes. You can set the class for the UI controller, and you can also get help regarding the code behind it. Now that I made some changes to my app, I'm going to create a remote repository and push it to it. If you recall, when we first created this project, we made a local repository to access that. We will go to the project navigation panel and select the second icon, which corresponds to source control. Here I'll find my local repo, and to create a new remote one, I will go to the remote folder and new tutorial remote. I already have my GitHub connected, so I'm just going to name the repo and create it. It is now going to push my files. If I wanted to commit later changes, I would simply select source control on the upper tab selector.
So I'm going to use storyboard rather than Swift UI, which is with interface building, because storyboard is more hands-on, it's more visual. It's a lot easier to pick up than just coding, learning how to use Swift and all that. So with storyboards, here's some storyboard files. So this is pretty much how the whole UI is set up. So in this storyboard, there's a view controller and a view. So you put UI elements in this view, and that's pretty much how everything comes together. So in XCODE, we have something called a library. So the library has different UI objects, and yeah, so we're gonna make a login screen. So we're gonna have a label and a text field for username, right? So here we drag it on to our view, just like that from the library, and we're gonna type in username, and alongside that we're gonna have the text field. So let's have username here, and let's add username as a placeholder text, just like that. That's that's username right there. So with the storyboard, pretty much anything else, we have what's called views. So here, yes, this is inside of a view, but we have specific types of views we can use to help place content and order content. Because let's say we just Command C, Command V this, Control C, copy and paste, and we just copy and paste a lot of this. We just have a bunch of just a whole mess, and it's going to be very hard to keep it all organized and nice and neat. So let's just undo all this. So this right here, we can just go and put this inside of what's called a horizontal view, horizontal stack view. And this, we can lay these elements inside. We can place it inside like this. And it allows it to be not only organized, but actually visually organized. And we can add our own spacing like this. And so when it comes to adding more complexity to this screen, what we can do is just have a bunch of stack views, and it helps us organize it very quickly. So we have a stack view for username, so let's make one for password. So we're going to just copy and paste that. And in here, we just type in password. Here, placeholder, actually put password. Perfect. So just like how we have horizontal, we have vertical. So actually, instead of going to the library, there's this little button here. It's called embed in. And we can just go stack view. And then it just places whatever you select inside of a stack view. Vertical, it automatically detected that, and boom, just like that. It's actually like kind of neat here. So let's add some buttons to log in. So button, it's going to say login. Another button, we can call that the forgot password button. So we're going to put login one word, forgot password. So these two boys right here, we can actually go here and do embed in, put in a stack view, and automatically does horizontal because they're laid horizontally to each other. And then we can, again, add a little bit of spacing, 20, that's fine. And what we can do is we can also place this in this vertical stack view that the username and password are in. So we can go just like this. Yeah, it places it on the top, so it can be easily changed, like it's a little finicky, just like so. Oh, that's actually not what I wanted. Place the element rather than the stack view. What's going on? Okay, so the stack view here. Ooh. What's going on? There we go. So we're dragging the whole stack view, boom, just like that. So yeah, it's pretty organized. It's pretty clear where everything is. So there's another way we can change the way stuff looks and organize them. So, and this little thing here is called add new constraints. So we can pretty much add some margins, or have it positioned so that it's static and very organized. Here we can actually just set width to a specific width. Let's just do 150. And so you notice that it changed, and then it also changed the password because they're in a stack view. So let's add a little title as well. So label, and we can just do sign in, right? Sign in. We can just change the font size to a little 35, and then we can put this in the stack view as well, just like that. And let's center the font. And so not only can we do constraints, which, by the way, if you go like this, you can do this, and you can set like different values. So you see I have like zeros, so it takes up the whole safe area. So let's just undo that. And what I'm going to do is I'm going to click here. It says align, so we're going to align it vertically and horizontally to the container, and it just centers it. So now we have like some type of constraint. It generated a constraint, and here it is right here. You can also delete these constraints.
About the interface builder to code section of XCODE today. So XCODE is pretty powerful, and the fact that the drag and drop interface builder is essentially all you need for most small interfaces. But oftentimes we want a lot of back-end code to our application. So for instance, this is a simple Galaga ripoff, essentially. So you have a fire button, a slider that moves you left and right, and some enemies at the top that'll fire things down at you. So with the interface builder, you can't really make things move all too easily. So instead we want to do that through an update function in our actual code. So this is my view controller code over here. So you can see I have a bunch of outlets over here. So these stand for interface builder outlets. So you can see as I mouse over them, they actually highlight each of the individual images on the screen. So some of these are images, some of these are labels, some are buttons, but essentially they're all just references to these objects on the screen so that I can manipulate them through the code. So you'll see over here we also have a timer. This is for the update function. This kind of game is going to take an update function once every 60 times a second, so that 60 times a second this code down here will run, and all of the logic for the game will progress. So it'll be pretty smooth, but you just need to make sure you don't overextend your CPU. So if you're like doing a lot of multitasking and running this game at the same time, you might not want it to run 60 times a second because the frames will stutter a little bit and it might move slower than you want it to. So if you see down here, we call the timer underneath viewDidLoad. load. So essentially, as soon as the screen loads up, we call the timer, and it starts updating the screen with all of this game logic. So we connect the interface builder objects through these little referencing outlets, they're called. So you can see if I drag one over, it highlights a little line in the code, and if I let go, it prompts me for a name, and I can call this anything that I want, any sort of variable name. And it'll actually connect that object directly to the code. But yeah, so it'll allow me to change anything that the builder interface can change, but I can do it dynamically while the code is running. So essentially I can change the position, I can change rotation, color, the alpha value if I want it to turn invisible. See, that's really useful with the pause menu. So I can say whenever this pause button is pressed, it needs to make the alpha of this pause 1, which means it becomes visible. Otherwise, make it 0. So it becomes invisible. So these kinds of things are really useful, and you can even add arrays. So all of these enemy characters are actually in an array, which is called a collection. So you can see that here, they're ants. So essentially, these are like little things that the cloud guys fire down. It's not super important what they are, but the fact that you can use them as an array makes it really useful for kind of just this collection of objects for certain logic down here. So I say if one of these is already fired out of this array, then I don't want to fire another one until it comes back. So something like that is really useful. Also for buttons, you have a little bit of extra logic. So this is a progress slider. So basically you can just choose a range within this, and it'll move the character left or right, but I want to get that value. I can access that value from the code as a kind of percentage location. So over here you can see I have my view controller value changed. So every time that value changes, I have this Boolean update to true, and then I can put in my code whenever this updates to true, do this part of code, so move the character left or right. Otherwise, you can tell that the slider isn't being pressed, so don't move the character. Same thing happens with the buttons, so they have a little bit of special code which says if you touch down inside of them, it tries to fire continuously, and then if you touch up, it sets that firing rate to false. So whenever you press down the button, it fires. Whenever you let up, it doesn't fire. Pretty simple, but all that code that's actually handling the firing from the character is handled inside of the update function, and these are just passing true and false booleans to it to keep it lightweight. The reason these can't be in the update function is because they are their own outlets, so these are actually parallelized within the processing cores and such, so that if you try to put it inside, it might not run properly. But if you just pass it a boolean that's kind of global to this update function, it happens a little bit better, a little bit more reliably. I'm not sure if it's still best practice, but it's functional at the very least. So that should be everything you need to know. Just remember, if you want to do updates within the code as the runtime progresses, rather than just upon start, you'd probably want to use code rather than this. One more thing before I finish is you can also add UI elements. So let button equal UI button. And then you can add sort of frames, you can add what kind of action it needs to take. So you can add all of these elements dynamically through the code as well. So if you want to spawn, say, more enemies as the game goes on, you just need to add more UI images, let's say, and say add more images of this enemy. And that should be everything you need to know. So have a good day. If you have any questions, PM me.